Hello and welcome back to Geometry. We're in Chapter 9, Section 2, Special Right Triangles. In the previous lesson we talked about the Pythagorean theorem using right triangles, and we could even use the Pythagorean theorem to determine is it a right triangle, is it obtuse or acute, using the inequalities. Alright, today we're looking at special right triangles. So here we have a triangle where this side is the same as this side. Okay, we would call that an isosceles triangle. Right, two sides are the same. Now, since this one is 90 degrees right here, right, this angle is 90 degrees, that leaves 90 for these two angles, which makes this 45, and this one also 45 degrees. All right, so we call this a 45, 45, 90. 45, 45, 90 triangle. Okay, that's a special triangle because these two sides are the same. So if we use the Pythagorean theorem, a squared plus b squared equals c squared. Well, a and b are both x, so I've got x squared plus x squared equals c squared. C is the longest side, opposite this right here is C. Right? So now to solve this, I would square root both of these. Right? Let me rewrite this, and we will get C, the square and square root cancel out, is equal to the square root of x squared plus x squared. Now, if I have something that I'm adding to itself, I can also write 2 times x squared. Okay, that's what C is. C is, I can also rewrite a product within a radical as the product of the two radicals. Okay, so this radical and the square can cancel out right here, and then I'm left with C is equal to x radical 2. So the side of one of the legs times radical 2. So this side here is x radical 2. If these two are the same length, then this is that length times radical 2. That's the 45, 45, 90 triangle theorem, and that is theorem 9.4. 9.4 is the 45, 45, 90 triangle theorem. Alright, let's look at a couple examples. Finding the value of x. Alright, here, if we know that this is a right angle, this is 45, right? Triangle angle sum theorem says that this also has to be 45 because they all have to add to 180. And since this is a 45, that's a 45, makes this 8. Therefore, this x is equal to 8 times radical 2. And there we go. That's our answer. Now over here we have an isosceles triangle. Therefore, if this is 90, then this must be 45 and 45. Base angles theorem says that in an isosceles triangle, the base angles are the same. Okay? If this is 5 radical 2, remember that the hypotenuse 5 radical 2 is the same as one of the legs, leg times radical 2, and the leg in this case is x. So x radical 2. So 5 radical 2 is equal to x radical 2. If I want to find x, I need to divide each side by radical 2. And then this cancels out. Boom, boom. And then x is 5. There we go. All right. Another pretty cool special triangle is this one. It's the 30, 60, 90. Okay, so here we have the 90 degrees. This angle is 30, and this one is 60. And the 30, 60, 90, the hypotenuse is twice the length of the shorter side. So if you know that this side is 3, then you automatically know the hypotenuse is 6. Pretty cool. And if this side is 3, the longer leg is just that side times radical 3. So if this is 3, then that's 6, and this is 3 radical 3. Super easy. Very fun. All right. So here we know the longer leg. So they're making this a little bit uncomfortable for us. But it's okay. We can figure this out. All right. We want to find x and y. We know this is a 30, 60, 90. So find x and y. All right. We know that the longer leg is the shorter leg times radical 3. So longer leg, let's write it out first. Longer leg is the shorter leg times radical 3. Okay, we know the shorter leg is 9, so we'll put that in. Shorter leg is x, so we'll put that in here. X radical 3, and the longer leg is 9, right? So we have this expression, and we want to solve for x. Divide that by radical 3. And now we don't want a radical in the denominator, so we've got to get that out of there by multiplying by a 1 fraction. So we're going to multiply this, 9. Remember this from algebra. Okay. Now we can multiply these two. Okay, don't go and cancel this out. I know that's tempting, but we just multiplied in order to get rid of the radical here. So now we have 9 times radical 3 over 3, because this is radical 3 squared. And now we can simplify here. 3 and 9, that gives us 3. So x is 3 radical 3. All right, let's look at a couple more examples. Here we have a road sign that's an equilateral triangle. So we know that every angle is 60 degrees in an equilateral triangle. All right, well, we don't know anything about an equilateral triangle. We didn't learn any special things about that because an equilateral triangle is not a right triangle. But what we do know is if I split this in half and make a right angle on the base, then I know that this angle is 60, this is a 90, therefore this is a 30, or I could split the 60 in 2. Alright, then I have a 30 here, 90 there, so I have two 30, 60, 90 triangles, and now we can figure out some stuff. Alright, so now we want to estimate the area of the sign. This is a bit of a challenging problem because you first have to figure out where is a triangle that I'm familiar with. All right, that I know something about. I know a 30, 60, 90, okay? Now I can find, for a triangle, to find the area, I need the base and the height. Right? I need base and I need height. Well, I could use the 36 as the base, but I don't know the height. Well, now I have a triangle here, and I could use this as the height. All right, I can find this short side here, or I can find this long side. I know the short side, this is half a 36. So that would be 18 right there. Or the long side is 36. I can use whichever one I want. And then the 30, 60, 90. I know that the longer leg is the shorter leg times radical 3. So height is 18 radical 3. Right? If this is 18, then this is 18 radical 3. All right, now we want to find the area. 1/2 base times height. Half base times the height. That means 1/2 times 36 times the height, which is 18 radical 3. That's 18 times 18 radical 3. And 18 times 18, we get approximately 561.18 square inches. All right, and one more problem here. We have a tipping platform. The ramp is used to unload trucks. How high is the end of an 80-foot ramp? Okay, so we know that this ramp, they've just told us, is 80 feet. Boom. We want to know how high is this right here. If the tipping angle is 30 and if it's 45. So the tipping angle is this down here. So if that's 30, this is the shorter leg. So in the 30, 60, 90, I'm going to make this 60. Remember, we have x, we have 2x, and we have x radical 3. Okay, if this is 80, and 80 is 2 times the short side, so 80 equals 2x, and the short side is x, then divide by 2 on each side, then we have x is equal to 40, if with an angle of 30. 40, come on. Oh goodness. Okay, so if the tipping angle is 30 degrees, the height is 40. Now, if the tipping angle is 45 degrees, then we have a 45, 45, 90. Okay, in a 45, 45, 90, if this goes up to 45, 45, then this right here is x radical 2. Right? And these two would be the same. So 80, and that's still 80, that hasn't changed. So 80 equals x radical 2. X radical 2. And we'd have to divide each side by radical 2. And 80 divided by radical 2 gives us x, or the height, is approximately 56.6 feet. Alright, so there you have it, ladies and gentlemen. Lots of fun, good times in geometry. Check in again next time for another fun lesson.